In the last video, we learned a little bit about confusion matrices. And confusion matrices give you the whole picture, but often we want to summarize things in just one or two numbers. And one of those most important numbers, which we've already seen, is accuracy. Accuracy tells us what percentage of the time our model is correct. And but when it gets it wrong, it doesn't really tell us what kind of mistakes are being made. And so we're going to be learning two metrics, recall and precision, which really you can think of as accuracy on a subset of the data, right? So there's still going to be fractions between 0 and 1, and but they'll kind of help us pinpoint where the mistakes are actually being made. Okay, so to review, here's a confusion matrix. Along the rows, I have what the data actually is. And along the columns, I have what the model thinks it is. And so right now I have zeros in all these places. But if I were to see an actual mouse, and the model predicted that it's a mouse, then I would go to the mouse row and the mouse column and increment that number by 1, right? And that's good. Anytime we're incrementing numbers on the diagonal for confusion matrix, that means we made the right decision. Here's an example of a wrong decision. If our model took a look at that picture, which is clearly a dog, and needs need of some grooming, and it predicted it's a cat, then we go to the dog row because it's actually a dog, and the cat column because that's what was predicted, and increment that. And so we might do this over our whole data set, and we have a bunch of numbers there. Now, from that, we might want to figure out what the accuracy is. And the accuracy is, well, what percentage of the times were we correct? And so the way I think of that is adding up all the numbers on the diagonal. That's how many we got correct. And then dividing by all the numbers in the matrix, right? So then look at 8 over 10 or 80%. And some observations here is that, this number is a fraction of kind of a subset over a larger amount. It's always going to be between 0 and 1. And the good number is always in the numerator for accuracy, so 1 is the best possible number. And so precision and recall have those same properties, but they're going to be a lot of different subsets of the matrix, right? We aren't going to be taking the whole diagonal divided by the whole matrix. So precision and recall, it turns out we can actually have these metrics for each class, right? So I'm actually going to have 6 different metrics here. I have dog recall, cat recall, mouse recall, and then similar dog precision, cat precision, and mouse precision. And so I'm just going to look at a few of these. So when I'm asking, well, what is the cat recall? What I want to know is when we actually have a cat, what percentage of the time is the model right? And so since I'm asking about what is actually the case, what I'm really doing is I'm dividing by the sum of numbers in a row, right? Because each row represents what the data actually is. So in this case, right, so the denominator will be the sum of the row, and the numerator will just be a single number, which is cat. How many times do we actually call a cat a cat? So in this case, we'll get 2 over 4. And so this is actually one easy way to remember recall versus precision, is because recall has an R and row also has an R. If I'm looking at dog recall, okay, so when we actually have a dog, what percentage of the time is the model right? I'm just looking at that top dog row, and I'm dividing dog by the sum of everything else. And in this case, we always get it right when we see a dog, right? So 4 over 4, 100% dog recall. The precision questions are asking something a little bit different. What we're asking here is, say for dog precision, when the model predicts that it's a dog, what percentage of the time is it right? And so when we're kind of looking at all the predictions now, we're talking about columns, right? Because each prediction is along a column. So in this case, we're dividing dog, top left, by the dog column. We have all the different things we predicted. We're going to get 4 over 6. And then similarly for cat precision, we're dividing cat by that cat column. We see that there's perfect precision here. And hopefully what you can see is that that they're making different kinds of mistakes, right? For the cat, we're great on precision, but we have a recall problem. For the dog, it's the opposite. We have perfect recall, but poor precision. And so these kind of two metrics that are kind of showing an error, right? Cat recall and dog precision are two ways of looking at that same problem. Sometimes we see a cat and we think it's a dog. The opposite is not true. I'm not going to talk about it more here, but I just want to give you some exposure to it. Often people try to reduce these numbers down to a single score. For example, there's something popular in machine learning called the F1 score. And a lot of these kind of simple scores are just combinations of these other metrics like precision and recall. Right? So these are kind of building blocks for other metrics. Let me head over and write some code for this to Jupyter Notebook. And in this case, I have my confusion matrix converted to a data frame, and I'm showing it down here, like so. Kind of similar to the one in the slides, but the numbers are larger now, and I also have a horse. And so the diagonal is good, right? So I can see this is actually not doing too bad, right? I have a lot of large numbers on the diagonal. I see that there's a horse problem. When I see a horse, it actually 90% of the time thinks that's a dog. The other problem I have, right, the other big number that's on the diagonal is right here. About half of the cats it sees get misclassified as dogs. Okay, that's a problem. So what I'm going to do is I'm going to look at, I've already produced this confusion matrix. I want to look at things like accuracy score, recall score, precision score, then finally this new metric balanced score that I'll introduce. So first, let's take a look at the accuracy score. So I'm going to run accuracy score, and I need to feed in the actual values and then the predicted values. So I'll do that. Actual and predicted, these are the two lists that I used to construct my confusion matrix. And I see that, oh, let me just run this again. And I see that the accuracy is 78, well, it's about 80%, right? So that seems pretty good. And the key thing to note here, right, is that when we have all these different classes, right, it might seem like we're doing good overall, but there might be cases where we are making a lot of mistakes, right? So for example, when we see a cat, we end up being wrong half of the time. Worse, when we see a horse, we're wrong 90% of the time. And so these other metrics are going to help us dig in and actually identify that. Okay, so let's say I wanted to look at recall for the horse, which I'm expecting to be 10%, right? When I see a horse, we only know it 10% of the time. So one way I could do that is I could, in my confusion matrix, I could get the horse value, right, from that bottom right, and I could divide it by the sum of all the values in the horse row, right? So I could do that, and I get 10% just as I expected, right? The shorter way to do that would be to use this precision score function that's actually built in to sklearn, right? So I'm going to call this thing, and so I have the true values and the predicted values. So I'll say actual, predicted, and I actually get an error here, and it's complaining about something called multi-class versus binary. These metrics are kind of set up for the simple cases where our two classes are just false and true, as opposed to 4 cases like dog, cat, mouse, horse. And so I have to clean that up a little bit. And the way I'm going to do that is, well, first off, let me expand this a little bit. I have to change this average value, right? So there's different ways to kind of summarize information. And I'm just going to set average to none. And actually, no, it's none like that. And then what it's doing is it's actually giving me 4 recalls, 1 for each of these classifications. Now the order might not be the same as up here. And so I'm actually going to pass in these labels as well to make sure that that I can kind of actually compare these numbers to the different values, right? So what I see here is that in terms of, actually I want to do recall first, I'm sorry. I'm going to do recall first. And so for this recall, right, I'm going row by row. And what I see is that recall for the dog is perfect. If I see a dog, the model is going to recognize it as a dog. It's also perfect for mice, right? If it sees a mouse, it's trying to recognize it as a mouse. For cats, right, if it sees a cat, 50-50 on whether it will correctly identify it. And then for horse, only a 10% chance that it correctly identifies it. Okay, those are my 4 recall numbers. Sometimes what I'll want to do is I'll want to kind of see how I'm doing overall by taking an average of those, and I get 65% in that case. And it turns out there's a special name for this average of recall scores, and that special name is the balanced accuracy score, right? So before, this accuracy score was saying, hey, we're doing 80%, but now, if I actually do this balanced accuracy score, it's only 65%, much worse. And in some ways, this is more meaningful. The only reason we were very accurate before is we were seeing very few horses, right? Even though our model is terrible with horses, we could just a good score because there were not many horses in the model, right? So when we're using these balanced metrics, it's trying to take into account for that. It's trying to say, even though we have more dogs than anything else, really, we're going to consider these 4 classes equally important in terms of coming up with our score. This will be a great one to use if you have a lot of imbalance in your data set, right? And accuracy can be a little bit misleading in that case. Okay, so that was the recall score. Let me similarly, instead of this, I'm going to actually do the precision, which I guess I was already doing earlier inadvertently. What happened there? There we go. So I'm going to paste that, and instead of that, I'm going to get this precision score. And now I see something different, right? I see that actually we do perfect on everything except the dog. And why is that? So when I'm talking about precision, I'm really going column by column. And what I actually see here is great, right? Except on the diagonal, I only have zeros in each of these columns. And so that means if this model is predicting a cat, a mouse, or a horse, it's probably right. Only when it's predicting a dog is there a good chance that it's making a mistake, right? In that case, only 2/3 chance that it's actually a dog, right? So this model likes to predict dogs a lot. If it predicts something else, it's sure. If it predicts the dog, it's only kind of 2/3 sure. All right, so that's we talked about accuracy, recall, balanced accuracy, which is an average of the recalls, and then precision. One last thing I want to talk about is binary classification. And so for binary classifications, instead of cat, dog, mouse, we have just false and true. And so I'm computing the confusion matrix here for that. And if I want to, I can compute these same metrics like I did before. So for example, if I do a recall score down here, I can pass in false and true for my labels. And why is that unhappy? Maybe because I didn't run this yet. There we go. I can run that, and it's telling me, okay, row by row. In that first row, 1/3 is correct, right? So, and in the second one, 70% is correct, right? Those are my 2 recall scores. So I can do that just like before. But it turns out when we're dealing with binary classification metrics, people will often just talk about they'll just talk about recall and precision without specifying what class they mean. And when they're doing that, what they're talking about is the positive class, right? So if I just talk about recall in general, I don't want that. I'm just trying to talk about recall in general. Look, I'm talking about that positive class. And the same thing for precision. And actually, this is probably the majority of the cases you'll see precision and recall used as kind of in this special case where I'm having a binary classifier. So just know that when we're doing that, we're talking about the positive class.